Assalamualaikum. Inshallah, we'll continue with the part 2, the killer part, where most of you find it as an obstacle lah kot. Okay, few more minutes. Hopefully semua dapat rehat sekejap tadi. Diffraction grading, kan? Kalau ikut konsep tadi tu, cukuplah satu peluang ataupun satu opening for us to spread out, kan? So kalau grading ni, that means there's a very small, tiny openings. So banyak, kan? So sepatutnya lebih banyak, lebih mudah kita nak spread out, kan? Tapi instead of spread out, dengan openings tu dia jadi opening. Tapi insyaAllah okay, kita cuba untuk nak buat yang terbaik. I think it's not really that tough. It's just a matter of knowing how to answer it sebenarnya. Itu saja. Macam if we just answer that one question dan kita tahu macam mana nak jawab, I think the other questions semua boleh jawabnya. Kita tengok dulu. Okay, so is everyone here? Can you just daftar masuk lagi sekali untuk second session ni? Just bagi tahu who is here and who is not here. Bagus juga bila kita buat break in the middle, kan? Tengok siapa yang boleh bertahan sampai tengah hari. Alright. Just wait for a few more minutes. Probably just give 1-2 minutes. Maaf kalau siapa yang dah berpuasa di bulan Sya'ban. It's good. Okay, moving on. Alright, Sheikh. As you can see that you're here. Alhamdulillah. So, first question. The diagram shows water waves passing through a gap. So, it is an aperture. What property of waves is being demonstrated? Just go for the definition, right? First one, diffraction, spreading out of waves after passing through an aperture or meeting an obstacle. Interference, when two or more waves meet at a point, there is a change in overall displacement intensity. So you can have interference if you have more than one gap. Okay. So kalau dalam gambar ni, sebab dia ada satu saja gap, so dia tak boleh jadi interference. Superposition, the resultant displacement at a point is equal to the sum of the displacements of the individual waves at that point. So this is the principle of superposition. What about polarization? The process of transforming unpolarized wave, that means a wave that is vibrating in more than one plane, into polarized wave. So waves in which the vibrations only occur in a single plane. So that is polarization. Dia ada polarization. Kalau dia travelling macam Ultraman macam ni, so dia lalu a vertical slit, so only the vertical component dia akan keluar. Right, so the answer is A. The diagram shows two loudspeakers connected to the same signal generator. A girl walks from position A to position B. Which statements describes what she will hear and gives the correct reason? So of course, it is a rise and fall sebab dia ada antinodal dengan nodal lines lah kan. So the two loudspeakers generate two coherent sound waves, two waves that are coherent, right? Intersects between each other. In between A and B will be an alternating of loud and quiet fringes. Dia taklah fringe sebab dia sound wave kan. Due to constructive and destructive interference occurring along alternating antinodal and nodal lines respectively. So the answer is A. Which is A and B kalau ingat rise and fall betul lah kan. Go in and out of phase betul lah kan. Cuma yang beza kat sini is either is it loudness or is it pitch. So why is it loudness and not pitch? So I'll give that as a question for you to answer in the comment section. I'll give you a hint. Mostly my questions semua ada hint-hint kan. Kalau question dalam bonus slide pun ada hint kan. So hint kat sini, in order to answer why is it loudness and not pitch, you go for the amplitude and frequency. Okay, so drop your comments to know why is it loudness and not pitch. Sebab between A and B dia lebih kurang sama kan. Alright. Question number 3. The graph shows two waves. Which statement is correct? So dia ada the red one and the blue one. So kalau comparing between amplitudes, the red one is larger. Kalau compare dari segi dia punya frequency, dia bukan wavelength, dia frequency. Why? Because it is a displacement time graph. Dari segi frequency tu, the red one is higher frequency lah kan. Sebab time period dia tu lebih pendek. Cumanya which statement is correct? So dia ada is between coherent and being phase, in phase or out of phase kalau kat sini. Yang ni discussion. Both waves have a constant phase difference, thus they are coherent and are out of phase. Why are they out of phase? Because their frequency tu tak sama. The difference in the frequency is not the same. If two waves are coherent and in phase, this would indicate that they are exactly the same waves. And unless kalau amplitude dia berbeza, itu cerita lain lah kan. That means they have no phase difference. But here, there is a phase difference. Kalau dia ada phase difference, maknanya dia out of phase automatically. Tapi is the phase difference constant or not? It is constant. So if it is a constant phase difference, that is actually the definition of coherence. Which is actually a question, guys. So nak kena faham ni. Kalau dia have different frequency, so automatically dia out of phase. So out of phase, sama ada dia coherent atau incoherent. Kalau dia incoherent, maknanya dia punya out of phase tu, dia punya phase difference tu sentiasa berubah-ubah. From one period to one period to one period, dia punya phase difference tu berubah. Tapi kalau kita tengok dalam this question, dia punya phase difference sama tak throughout time? Yes, sama. Sebab kalau kita tengok kat sini kan, oops, where we can see for the red one, this is the period. But for the blue one, the period is here. So kalau ikutkan by definition, the phase difference, what is it here? Kalau ikutkan by definition, the phase difference is this one. This is the value of the phase difference lah kan. Kalau ikutkan, so this phase difference throughout the wave, are they the same? Yes, they are the same for every period. So if they have constant phase difference, so that means they are coherent. Are they in phase or are they out of phase? Automatically they are out of phase. Sebab dia ada phase difference. Kalau dia constant phase difference with zero difference, So dia bukan constant phase difference langsung, maknanya dia tak ada phase difference langsung. So they are actually two waves with the same frequency. Okay. Amplitude mungkin berbeza kat situ. Alright. So the answer is B. Moving on. A student sets up an experiment to show interference of light. He uses two small red LEDs as the light source. Which of the following explains why he will not be able to show interference? So two independent LEDs will generate two independent waves that might not have a constant phase difference. Thus, the coherence is compromised. Since coherence between the two waves is a prerequisite for interference of an ideal experiment environment. Coherence maknanya kalau lah dia dua waves tu dia tak coherent, can we get interference? Kita boleh dapat interference tapi kita tak boleh nampak sangat dia punya interference kat situ. So the answer is D. So there should be a kat sini. This is okay. Alright. Moving on kat sini. An experiment is set up to demonstrate interference from different types of electromagnetic radiation. The apparatus is shown below and the dimensions are kept constant for all types of radiation. Which type of radiation will produce fringes which are closest together? So yang ni dia guna electromagnetic radiation. So yang ni you have to know the spectrum lah based on chapter, I think it was chapter what? Chapter 7 if I'm not mistaken. You have to know the electromagnetic waves. Chapter 8 lah, waves part 2. Electromagnetic waves. So you have to know the radio, micro, infrared, visible. Visible dia ada 7. Ultraviolet, X-ray and gamma rays. So dia kata which type of radiation will produce fringes which are the closest together. So bila dia indicate closest together, so we want to find out of these 4 electromagnetic waves, which wave will have the least ataupun the smallest wavelengths lah. So the answer, waves that have shorter wavelengths will produce closer fringes. Dia punya dekat screen tu ataupun here is the photographic film. Dia punya diffraction is closest between each other. So we know that y is equals to lambda d over d. So the smaller the lambda, the smaller the y. So kita nak tahu y lah kan, produces fringes. So the answer is D, which is ultraviolet radiation. Ultraviolet is here. 10 to the power of minus 8 meters compared to red light 700 roughly. Blue light ada kat sini. Infrared radiation of course 10 to the power minus 5 lah kan. Okay. Alright, so everybody clear? Moving on, subjective part 2. Yang ni masih lagi okay kan? Describe what is meant by diffraction, spreading of the waves. Okay. After passing through an aperture or meeting an obstacle. Part B, electromagnetic radiation of frequency 7.5 times 10 to the power of 9 is directed towards a slit of width 6.0 centimeters. So kalau electromagnetic EM radiation frequency 7.5 times 10 to the power minus 10 times 10 to the power of 9. So what type of wave is this? Got a question here by Putri Irdana. Is ultraviolet UV light visible? It is visible in certain conditions, right? It is visible in certain conditions. It is not visible in the naked eye. Okay. Part B, part 1. Determine the wavelength of the radiation. Straightforward using the wave equation. You quote the wave equation, you'll get 1 mark. Lambda is equal to V over F. So watch out for the conversion. So electromagnetic wave, you know the speed is speed of light. So lambda is equal to 4 centimeters ataupun 0.04 meters. Alright. So it is not 6 centimeters lah kan, because 6 centimeters is the slit of width. Right. Explain whether the radiation will be diffracted at the slit or not. So the question, Will there be diffraction at the slit? Yes, there will be diffraction at the slit, since lambda is less than d, with d is equal to 6 centimeters, but d is the width of the slit, but with a poor spreading. Sebab lambda less than d. Yang ni rasanya Amir tanya soalan itu dalam group, so just refer to the diagram. No? Okay. Right. Explain what is meant by coherent sources. So we've got coherent laser light and we've got incoherent LED light. Ni just example. Coherent are wave sources that have constant phase difference between each other. So if the phase difference is 0, so that means they are likely the same wave, ataupun they are coherent but no phase difference lah kan. Although if different waves with phase difference, they can be coherent as well, as long as they are constant. Contohnya macam ni lah, example. Okay, 1 mark, straightforward. The diagram below shows the displacement time graphs for two waves A and B. What is the phase difference between the two waves? So kalau kita tengok A, kita ada A kat sini, dan kita ada B. What is the phase difference between the two waves? It is not 2 pi, it is not 360 degrees, but instead it is only 180 degrees. Why? Because you can see it here. The darker wave is A. It's either of them lebih dahulu ataupun lebih kemudian. Okay, it's 180 degrees. Alright. So you can either answer it in degrees ataupun in radians, but make sure you put it the units. Right. B. The two waves A and B are combined. Can you guys hear me clearly? Sebab macam ada noise dekat sebelah kiri dan kanan. Very sorry. Sebab orang semua dah mula gerak-gerak untuk nak lunch. This is the nasib kerja daripada rumah. Everything okay? Kalau ada tak clear apa semua, beritahu. The two waves A and B are combined. Name the type of interference that will occur. So you can see here, it will become a destructive interference because they are exactly out of phase. Cumanya dia akan dapat tak zero amplitude. Maknanya a total destructive interference. No kan? Dia akan ada small waves. Okay, small waves according to the profile of A. Maknanya dia menjadi wave yang ada phase ikut A, the frequency is like A, tapi dia small amplitude lah, because it gets cancelled out by B. Right. Number 9. The diagram below shows an arrangement used to demonstrate the interference of water waves. Constructive interference occurs at point A. So, yang ramai orang buat salah kat sini ialah apa? Tersalah tengok point A dengan point B. This is point A. This is point B. So, bila orang tersalah tengok path difference of waves from the gaps S1 and S2, dia nampak 15.5 dengan 14. So 15.5 tolak 14. So jadi automatically 1.5. But that is point B. Dia cakap point A. Yes, Yusof, selamat datang. Tumpang boleh, tak ada masalah. Bayar lah. Tak ada, saja kacau. So constructive interference, path difference. So kat sini apa jawapannya? For a double slit case, any constructive interference that occur would give a path difference at multiple values of n lambda, where n can be 0, 1, 2 or 3. Kat situ. Okay? So that is the answer lah. It is not 1.5 centimeters. Why is it not 1.5 centimeters? Because it is not point B. We do not know the exact distance between S1 and S2 to point A. Okay? So itulah dilema dia. Question part B. The water waves have a wavelength of 3 centimeters. Determine the path difference for the waves arriving at point B. Name the type of interference taking place at this point. So, kalau lah siapa yang jawab 1.5 dekat part A tu kan, macam mana you boleh tahu part B tu ialah type of interference apa kan? So, dia memang ada 2 points lah, 2 different points. Wavelength is 3 centimeters. So, path difference is, so kat sini you deduce the path difference between S1 and S2 to point B is equals to 15.5 minus 14, which is equals to 1.5 centimeters. So you compare this value of the wavelength, 1.5 centimeters, with its initial wavelength of 3 centimeters. What do you get? Since the path difference is 1.5 equals to 3 centimeters over 2, which is equals to lambda over 2, it's a half lambda, that is the path difference. So the phase difference is half, which is pi, or 180 degrees. So at point B is a destructive interference. So that's how you get the 3 marks. Okay. But only 15 people joining online. Tu pun ada pemerhati daripada group 1.1. So I'm not sure the exact 1.2 berapa orang. Okay. Question number 10. A microwave source is directed towards a metal plate with 2 narrow vertical slits. A receiver is slowly moved along the line XY, as shown in the diagram. Okay, terkejut sekejap. Sorry. Explain why the receiver registers a series of maxima and minima. So this one sama je dengan yang sebelum ni. Due to diffraction. So diffraction and interference lah. The transmitted microwave gets diffracted at the 2 vertical slits, causing diffraction between the 2 current sources from at the two slits. Part B, belum lagi part B, dia ada 3 marks punya ni kan. So what happens after diffraction? Interference between the 2 waves causes both constructive interference and destructive interference alternately at each antinodal and nodal lines. So kalau you nak lukis kat sini pun boleh juga. Ya, ada dekat dalam, similar to your notes lah if you want to draw that one. So what happens at the constructive interference ataupun antinodal lines, you have maximum signals, but vice versa for the destructive interference. So altogether you get 3 marks here. So now calculate the separation between adjacent maximas. Y is equals to d lambda over d. So the equation becomes originates from here. So y is equals to d lambda over d is equals to 80 centimeters times 2.8 centimeters over 4 centimeters. You get 56 centimeters. 56 centimeters ataupun 0.56 meters lah. If separation between the slits D is halved, so this is the second C part 1 and C part 2. Both have the same answers. What happens? Dia akan jadi double. So if separation between the slits D is halved, so you base on this equation. Y is equals to d lambda over d. So if the separation between the slits small d is half, so what happens to y? Since y is inversely proportional to d, so it will be double, which is 112 centimeters. Next question, if the distance between the slits and the receiver d is double, so d ni dia darab 2. So apa jadi kalau d darab 2, y pun darab 2 lah. Since y is proportional to d. Okay. Are you guys still with me? Tak tahu berapa ramai yang masih lagi ada. Just lunch time already. Bear with me just a few more minutes. Monochromatic light is incident normally at a diffraction grating with 60 lines per millimeter. The 10th order maximum is observed at an angle of 19 degrees. Determine, part A, the spacing between the centers of the adjacent lines on the diffraction grating. So spacing between the centers of adjacent lines on the diffraction grating, D is equals to 1 over 60. You get the answer is 1.67 times 10 to the power of minus 5. So dia tengah tanya spacing between dalam diffraction grating tu. Maknanya alat yang digunakan untuk nak alat untuk nak diffractkan dia punya value. Right. So 1.6 times 10. So either this ataupun you straight away convert it by placing 10 to the power minus 3 on top kat sini pun boleh juga. That is the most straightforward way. Dimasukkan terus dapat jadi meters. Kalau yang ni you dapat ni and then you kena buat lagi untuk nak dapatkan conversion kepada meter kan. So it's a double step. Cuma kita buat macam ni just untuk nak tunjukkan how the process is, because this is the first question. And the next series tu just ikut this template je lah. When you are given the number of lines per millimeter, find the spacing, which is D. If you recall in our tutorial last week, it's the other way around, isn't it? We were given the spacing between the diffraction grating and we were asked to determine how many number of lines per millimeter. So yang ni dia terbalik. Okay. So part B. So how do we determine the wavelength of the incident light? So we've got kat sini dia kata dia dah bagi hint kat kita 10th order maximum. So if you recall, so in our equation n is equals to 10 lah. So which equation I'm referring to? D sin theta n is equals to n lambda. So here n is equals to 10. So we have already been given theta 10 is equals to 90 degrees. So we plug in into the values into our formula. So you get lambda is equals to d sin theta n over n. D kita dah dapat kat sini. So n sama dengan 10. Theta n is 90 degrees. Should be no problem. You should get this answer. Okay. Siapa yang tak dapat tu jawapan, boleh tanyalah soalan. Ada soalan? Saya baca soalan Nurin Afika. Sir, it's okay right if I don't write down the exact value? Instead, I just write down is twice the original value. Yes, it is accepted. Tapi sebab benda ni quantifiable kan, tak salah untuk dia nak bagi jawapan yang dalam bentuk nombor kan. But because it's only 1 mark, so you don't actually have to tekan calculator darab 2. Although dia taklah susah sangat kan nak buat benda tu. Still acceptable. Alright, question number 11. Masuk question number 12. Okay, I think this one still okay lagi. Masih lagi boleh. Walaupun ada yang memang dah pening dah. Masuk sini dah pening. Tapi tak apa, kita cuba slow-slow insyaAllah. Mungkin waktu berjawab hari tu kalut, tak baca bismillah mungkin. So tu yang ilham tak datang kan. Okay, given what is the wavelength of yellow light? 5.5 times 10 to the power minus 7 meters. Diffraction grating D, yang ni yang saya cakap kan, kita terus dapatkan dia punya grating spacing 3.33 times 10 to the power minus 6. Using the diffraction grating equation, kita tahu d sin theta n equals to n lambda. Kita nak cari apa? Theta kan. Cumanya soalan ni dia bukannya calon-calon soalan nak cari theta je. The angle between first order and second order. Maksud dia apa? So kita ada diffraction grating kat sini. Kita ada coherent source, monochromatic light which is yellow. So kita tahu, for example, this is n equals to 0. The zero order kan. So kat sini kita akan tahu dia akan ada bright fringe at n equals to 1, which is the first order. And then kat sini dia akan ada angle. Betul tak? It is theta 1. And then dekat lagi satu kita akan ada n equals to 2. So n equals to 2, we have another angle kat sini. Theta 2. So we can find out what is the value of theta 1 and what is the value of theta 2 using this equation. Kan? So first order maxima, n equals to 1, you get theta 1 equals to 9.5 degrees. And then second order maxima, theta 2 is equals to 19.3. Kan? So theta 1 here is 9.5, this one is 19.3. Is that the final answer? No, it's not. We have to find out the angle between it. So, difference in angles. What is the difference in angle kat sini? Theta 2 minus theta 1. So, you get the value is 9.8. I think seorang kot, dia tak kira the angle. Betul tak? Tapi tak apalah. Okay. So, kat mana yang mungkin orang stuck? Nak jawab benda ni ialah nak gunakan equation diffraction grating kat sini. D sin theta n equals to n lambda. Which is actually quite straightforward, betul tak? D is the diffraction grating spacing in meters. Theta is the angle, n is the order. N adalah order, lambda is the wavelength. So dia sebenarnya menggunakan 1, 2, 3. 3 variable saja. And then you just have to know what is the order. So it's not really that hard. It's a matter of understanding the question. Theta 1, theta 2. And then find the difference. Betul tak? Do you agree with me? Kat sini. So up till now, do you have any questions? Minum air jap. Okay, moving on. Question number 13. Last two question. Kita ada blue wave of wavelight. This is the lambda 4.5 times 10 to the power minus 7. Incident normally at a diffraction rate with 100 lines per meter. So yang ni automatically kalau kita tahu 100 lines per millimeter, kita boleh dapat directly D dia kan. Betul tak? Okay, we've got a question. Kenapa kita nak inverse the diffraction grating? The small d. Because d is the spacing, diffraction spacing. Tapi apa yang kita diberi ialah the number of lines. So diffraction grating ni apa? Okay, tu soalan lah kan. Kalau normal diffraction, kita ada slit kan, ataupun kita panggil aperture kan, aperture. So aperture ni, what is the spacing, what is the units for the aperture? D, it should be in meters, betul tak? This is where the wavelength spreads. Dia keluar, wavelength tu dia keluar dekat, dia punya wave tu dia keluar kat sini kan. So let's say this is the blue. So wave dia masuk kat sini, lepas tu dia gets diffracted kat sini. So yang lainnya untuk diffraction grating ni apa? Diffraction grating ni ialah satu aperture yang ada banyak lines ataupun banyak openings. So kalau kita zoom in, dia punya diffraction grating akan jadi macam ni. Dia macam apa? Dotted lines. Sorry. Oh, effort ni nak lukis ni. Bear with me. Tapi yang ni zoom in lah, zoom in version. So this distance dia kata ada 1 mm, assuming that yang ni dia ada 1 mm, assuming this is 1 mm. So how long is 1 mm? It's very small, betul tak? 1 mm is 0.01 meters. Very small. 0.001. 0.0001. Betul tak? 10 to the power minus 3 kan. So within 1 mm dia kata ada berapa line. Maknanya ada berapa slit yang kecil. So kat sini dia ada 100. Oh banyak ah. Tapi yang sebenarnya 500, 400 lagi banyak. So lagi banyak slit tu kita panggil tu yang kita panggil grating tu. Grating dia macam perforation lah. Untuk kita nak koyakkan kertas tu kan. So what happens is this wave light, dia lalu diffraction grating ni. So dia keluar kat sini, dia masuk kat sini. What happens bila dia lalu dia punya diffraction grating ni? Dia akan diffract juga. Okay. So it is not just one slit, tapi dia ada banyak. So here we are only given 100 lines per millimeter. Tapi how long is one diffraction grating kat sini? How long is it? Berapa besar kan ni? Yang kecil ni, yang kecil ni. So dia punya length kat situ ataupun berapa besar tu answer, berapa besar? When we take the inverse 1/100, kita akan dapat 10 to the power of minus 5 millimeters, which is logical. Kan? Because the diffraction grating is not 1 millimeter, it's very small kat sini. Yeah, ini. This is the value. The length in which the wave light goes through is only 10 to the power of minus 5 meters. It's very small. Even this small aperture pun is enough for the light to be diffracted. Macam tu. So sebab tu, in this question, it is not given the diffraction grating length D kat sini. Dia tak bagi value of D. Tapi dia just bagi tahu dalam 1 mm ada 100 line. So kalau kita ambil diffraction grating tu, what is the length of one grade, one slit? Is 10 to the 1 minus 5. That is the value that we have to use in this equation. Because D is not 100. D is the inverse of it, the inverse value, which is the length. D is not length. 100 lines per millimeter is not length. It is just to show how many lines are there in 1 millimeter. What is the length of one line? So sebab tu kita ambil inverse. Okay, so hopefully that actually answers your question of kenapa kita nak inverse. Lunch apa hari ni? Tengok dulu apa yang ada dekat dapur. Okay, you guys lunch apa? Tapi for sure lunch hari ni sekarang ni lah lunch dengan lunch fizik lah. Nak buat macam mana? Okay, the angle at maximum number of orders. So yang ni yang sangkut ni. Ni yang sangkut ni. Sangkut. Okay. Mana ni? Okay. So dia kata, what is the maximum number of, kita ambil nak color apa? Kita ambil color, kita ambil light blue maximum number of orders. How do they make very small slits? Okay. So sekarang ni, kalau kita belajar diffraction ni kan, okay, kita belajar diffraction, we look at this, even this slit lah we have, this is the diffraction angle theta. In your point of view, what is the maximum angle the diffraction can go to? Maximum angle. Maknanya diffraction kan, this is one light, kalau kat sini theta equals to 0, this is the 0 order kan. And then dia akan increasekan theta tu, you have N1, you have N2, you have N3, N4, N5. So increasing number of orders akan increasing number of theta kan, because theta kat sini is proportional to N kan. See. So what is the limiting factor kat sini? Is lambda is constant, okay? Lambda is constant, D is constant. What varies is actually is either N or theta. So we want to know what is the maximum number of N. So how do we know the maximum number of N? Is the maximum number of theta. So what is the maximum number of theta here? The maximum number of theta here is actually 90 degrees. Can the wave go beyond 90 degrees? Tu macam soalan agak tak cerdik lah kan. If you go theta greater than 90 degrees, let's say for example 120 degrees, maknanya dia apa? Dia terbalik. Dia ke belakang. This is not reflection. And this is not a refraction pun. It's a diffraction kan. Can it go 180 degrees? No, 180 degrees is reflection. But this one is just diffraction. So the maximum number of orders is determined by the maximum angle, where angle is 90 degrees. But can it occur to 90 degrees? Probably not. It's actually theta less than 90 degrees. Okay. So, and you substitute the value of theta is equals to 90 degrees. So, soalan ni sebenarnya dia memerlukan kefahaman tentang maximum tu lah. The value of the maximum kan. Because you see D is constant, lambda is constant. And kita nak cari sebab that is the question kan, maximum number of orders that can be observed. So what can be changed is actually theta. Theta dia boleh berubah. Kosong ialah the first order. 90 is the maximum number of. So theta max is 90 degrees. So n max is equals to what? Substitute the values, you get 22.2. So order is in integers. So the answer is 22 orders lah. So dia boleh ada 22 fringe dekat atas dan dia boleh ada 22 fringe kat bawah. Ada yang jawab 22 kali 2 44 tambah 1 jadi 45. Tapi if you notice diffraction, top and bottom sama saja number of orders. So dia come in pair. So the answer is still 22. So you do not have to double it, right? That is question number 13. If you use a glass object, then you have a prism. That prism will become a refraction. It's not a diffraction. And we are using a diffraction grating. Okay? So that is beyond the scope of this question. Question 14a. Answer the following questions with supporting calculations. Masya Allah. Dia bagi segedebuk 6 markah. Dan part B 4 markah. So this type of question, you susah nak carilah dekat CIE kan. Ni mungkin Excel punya board kot. But the concept is still the same. You are given a diffraction grating with 40 lines per millimeter. So yang ni sama je. Automatically you can get D is equals to the inverse of it. The diffraction grating is mounted on an instrument that can measure angles within plus minus 0.1 degrees. Can this instrument be used to determine the individual wavelengths of spectral lines of wavelengths 589.6 nanometers and 589 nanometers? So kalau you have 589 juga kan, cuma beza dia lah 0.6 and 0.0 nanometers. So how do you do this? Macam very tak membantu langsung kan. So adalah yang dapat jawab, I think dalam seorang dua je lah. Yang lain memang macam-macam cuba untuk nak jawab juga kan. Masya Allah, I applaud your efforts in trying to answer. Alhamdulillah. So I'll give you credit for that. So first you find out D automatically kan. Bila you diberi saja 40 lines per millimeter, you find out what is the diffraction grating length. And then you code this equation somehow. And then you are given these two values. Right. Now, dia kata apa? Can this instrument be used to determine the individual wavelengths of the spectral lines? So it can measure the angles within plus minus 0.1 degrees. So what do you do using the same concept? What is the maximum diffraction angle? Which is theta equals to 90 degrees. So you first look at the number of maximum orders kat situ. So the maximum number order sama juga, N1 is equals to 42.4, and it's roughly the same, sama je. So therefore, the maximum diffraction angle at maximum order. So yang ni kita letak theta equals to 90 degrees, betul tak? Kita letakkan theta equals to 90 degrees. But does the diffraction occurs at 90 degrees? No, it does not. We just use 90 degrees as a benchmark of knowing what is the maximum number of order. Once we deduce that, for both wavelengths, the maximum number of order is 42. What do you do with this? The maximum diffraction angle at maximum order for both wavelengths, theta 1 and theta 2, will correspond to 8.17 and 82.1. So the difference between these two angles is 0.4. Since the accuracy of the instruments is plus minus 0.1 is less than 0.4, thus yes, it can measure the angle. Did you guys get that conclusion? Kalau tak dapat conclusion, probably you can rewatch this video again. Maknanya apa? You kena cari dia maximum diffraction angle kat situ. So maximum diffraction angle is what? 42. Okay. So kita just nak tahu dia punya spread lah tu kan. Dia punya spread kat situ. So at the maximum, kalau kita tengok kat sini, kita ada diffraction angle kan. So this is n equals to 0. So the maximum spread, this is the first spectral line, and this is the second spectral line. So both of this happens at n max. Kat situ. So at n max, what is the value of this angle? Here we deduce it as 82.1, and here as 81.7. So kat sini theta dia ialah 82.1. Theta kat sini ialah 81.7. Okay, so the difference between this one is 0.4. Because the maximum is 0.4, so it still can detect the difference. Okay. Kenapa kita nak ambil n max? Alright, that's a good question. I noticed that most of you, what you did was you ambil the first order kan, n equals to 1. You ambil n equals to 1 kat sini kan, n1. So when you ambil n equals to 1, theta 1 kat sini lebih kurang you guys dapat 13 point something, betul tak? And then here n2, theta 1 here lebih kurang pun ada yang dapat 13 juga, betul tak? Ni bagi yang cuba juga untuk nak jawab lah. Tapi ada yang tulis terus, "Sir, I don't know this question." Tak boleh nak jawab. Tak payah tolong, saya pun tak payah tolong. Tapi I think most of you, you just substitute n equals to 1 untuk nak dapatkan angle dia kan. Tapi kenapa kita ambil 42? So kalau kat sini, you nampak tak beza dia? Kalau you just measure dia punya angle dekat nth order ni, mungkin you boleh deduce kat sini, yang ni ada khilaf juga. Ada yang kata yes, ada yang kata no, walaupun dia buat kiraan sama. Sebab ada yang kata this one is 13.4 something, this one is 13.5 something, because the accuracy is 0.01. That means this instrument cannot be used, dia kata macam tu. But this is the first order So kalau dalam first order kita dapat tahu yang dia ada difference yang kita boleh guna instrument tu. Tapi it's not enough. We have to know what is the value at n max, because this is the most maximum that the diffraction can go. So based on this one, kita tahu dia punya difference is 0.4. So kalau benda tu dia lebih kecil dekat dia punya maximum, so that's when that instrument cannot be used. But here is only 0.4. So kalau 0.4, it still can be used. 0.1 guys. Okay. So it's a matter of finding out the maximum order guys. Alright. Cuba untuk nak hadamkan, insyaAllah. Okay. Yeah, it's 1.3. Can't remember. Tapi most of you did the calculations kan? 1.34 and 1.35 if I'm not mistaken. Okay. So, screenshot benda ni. Try to untuk fahamkan benda ni. Moving on, 14B. So, now dia kata, white light is incident normally at the grating. Estimate the angle between the extreme ends of the spectrum for the 10th order maximum. Okay. Here, this question B has got nothing to do with question A. Sebab spectral lines 589.6, 589, what color is it? You can refer it back. Tapi yang ni dia terus kata, white light is used. So it's not wavelength of 589 sahaja. White light. So kalau white light, maknanya dia ada range of colours, kan? Dia ada maximum dan dia ada minimum. So dia akan dapat rainbow lah kan. Tapi kalau yang tadi tu, dia punya incident ataupun dia punya source tu ada dua spectral lines lah, 589.6 and 589. Tapi untuk part B ni dia ada white light. So that means it has the entire spectrum of lights. White light lah kan. 7 warna tu. So the question is, estimate the angle between the extreme ends of the spectrum for the 10th order maxima. So automatically bila kita tahu sini 10th order, that means n is equals to 10. Alright, n is equals to 10. Automatically we know that. Cuma ya, extreme ends. So macam mana kita nak tahu extreme ends? Kena tahulah dia punya dia punya spektrum tu. Michael Jackson kena halau balik India Utara. So it's M and U. Sorry, old school punya rhyme kan. Merah dengan ungu lah kan. Ungu is violet. Okay. So you got lambda red is equals to 700. Lambda violet is equals to 400. This is an estimation. So it can be 700, 740, 400 ataupun 430, whatnot lah. Yes, you have to memorize the spectrum. I've been telling you several times, not only the spectrum of light, white light yang spectrum tu, tapi juga the entire electromagnetic spectrum. Okay. So for the n equals to 10th order maxima, lambda red is equals to what? Make sure you substitute n is equals to 10, you get 9.21 degrees. Lambda violet is equals to 16.26, you substitute n equals to 10, the value of d is sama, 10 to the power minus 3 divided by 40. So the difference between the angle, this is what we want. Okay, yang ni this is red light, this is violet. Okay, between two extremes, the maximum lah which is at the 10th order maximum. Bukan yang kita nak cari 10 n maximum tu apa, tak, dia dah beritahu dekat n equals to 10th order, ekstrim dia apa, daripada merah sampai ke violet. So the answer is 7 degrees. Wallahu a'lam bissawab. Itu sahaja untuk kita hari ini. So I think we've spent less than 1 hour discussing on the review for this question. If you have any questions, you can drop at the comments ataupun proceed dalam kita punya perbincangan dekat Telegram for group 1.2. Adapun kalau nak repeat boleh at 2 o'clock I'll be discussing with 1.1 on the same subject matter. Probably you can ask if you have any arising question and you've got nothing better to do. So that's it for now. I hope you guys have benefited from this session. It's okay if the results are not really that good, but because it's better now that you realize what you have to know and what you do not have to know, rather than the final kan. Tapi we will be giving supplementary questions for you to practice and for you to submit back in order to increase your overall marks, inshallah. So I guess that's all for now. The next live session would be on Thursday, when you have already submitted your feedback notes for the next chapter. So on Thursday, that would be 1 day before Ramadan. Inshallah, I would like to take this opportunity to remind everyone the dua of the Prophet Nabi Sallallahu Alaihi Wasallam. Allahumma barik lana Sha'ban, Allahumma balighna Ramadan. Oh Allah, bless us in this month of Sha'ban, and oh Allah, please make us rich and have the opportunity to meet again Ramadan this year. Although the environment and the situation will be different, because we will be celebrating Ramadan in our houses and in our homes, but during this RMO, Restricted Movement Order atau PKP kan, but we'll just have to make the best of it, insyaAllah. Wallahu alam. So I'll be answering your questions later dekat dalam ni comment section. Aqulu qawli hadha wa astaghfirullah li wa lakum. Assalamualaikum warahmatullahi wabarakatuh. We'll end this session with tasbih Quran Surah Al-Asr. Subhanakallahumma wa bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal 'asri innal insana lafi khusrin illa alladhina amanu wa amilus solihat wa tawassaw bil haqq wa tawassaw bis sabr. Alhamdulillahirabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.